In this video, we're going to convert scientific notation to standard form. Standard form is nothing more than just a regular number, okay? So we're going to take our scientific notation, which is basically a shortened version of a number, and we're going to convert it to the actual number. So here you can see that I have a 3.75 times the base of 10 to the negative fifth power. What that negative exponent tells me is that my converted number is very small. So I'm just going to make that note here. Negative exponents usually mean that it's a small number. With that said, positive exponents usually mean that it's a very large number. Okay, so since I can see that this is going to be a small number, I know that I'm going to move my decimal to the left. Okay, and how many times am I going to move it? 5 times. So 5 times to the left. So if my original problem is 3.75, I know I'm going to get 1, 2, 3, 4, 5. So that would be my decimal right there. And I'd have 1, 2, 3, 4 zeros. As you can see, this is a very, very small number, but it is in standard form. So we're going to take a look at the second example. You can see here, this is a positive exponent, so I know it's going to be a very large number. That means I'm going to be moving my decimal to the right this time, and I'm going to move it 8 times to the right. So here I can see that my decimal is currently here. There's 2 numbers for me to move, but I still need to move it 6 more times. So that's where the zeros come in. So there's my 1, 2, 3, 4, 5, 6, 7, 8. So as you can see, this is a very large number. And this is where we would stop. Again, standard form is just a fancy way to say our large number. Now let's take a look at converting standard form to scientific notation. So same concept. If it's a large number to start with, I know that my scientific notation is going to have a positive exponent. If it's a very small number to start with, I know it's going to have a negative exponent. So here, the first example is a larger number, so I know it's going to have a positive exponent. I also know that the decimal is right here, even though it wasn't written in the original form, right? The decimal always goes in the back of the whole number. So the whole point of writing a number in scientific notation is so that there is only one digit in front of the decimal. Okay, so I just made that up. We want to move the decimal until there's only one digit. So here I need to move it 1, 2, 3, 4 times so that there's one digit in front. And when you write scientific notation, it's always to the base of 10. And since I moved it 1, 2, 3, 4 times, it's going to be a positive 4. So proper scientific notation, always one digit in front of the decimal. That's the one thing you want to make sure your final answer looks like. And pay attention to whether it was a large or a small number to start with, because it helps you keep the signs correct. So in this second problem, I can see that it is a very small number. So I'm already thinking ahead to know that exponent is going to be negative. So how many times do I need to move this decimal so that only one digit is in front? 1, 2, 3, 4 times. So I end up with 7.6 times 10, and this time instead of a positive 4, it's going to be a negative 4.